Hello and welcome to SigmaXL video tutorials. In this video, we'll be looking at the analysis of means nonparametric transformed ranks tool found within SigmaXL. ANOM Nonparametric Transformed Ranks is complementary to a Kruskal-Wallis test and would be used with non-normal data. To begin, we'll be using a sample data set found within SigmaXL called customer data. To open the dataset, click SigmaXL, Help, Sample Data, and then find the file customerdata.xlsx. To start the ANOM Nonparametric Transformed Ranks tool, click SigmaXL, Graphical Tools, Analysis of Means, ANOM, ANOM Nonparametric Transformed Ranks. Ensure that stacked column format is checked. Select Overall Satisfaction, click Numeric Data Variable Y. Select Customer Type and click Group Category X. Set the alpha level to 0.05. Clicking OK will provide us with the analysis. Here we see that Customer Type 1 mean transformed rank satisfaction score is significantly below the grand mean, and Customer Type 2 is significantly higher. This is consistent with results that are obtained in a Kruskal-Wallis analysis that I demonstrated in another video. The varying decision limits are due to the varying sample sizes for each customer type, with smaller sample size giving wider limits in a manner similar to a control chart. If the data are balanced, the decision limit lines will be constant. To demonstrate this, open anomexamples.xlsx, click Help, Sample Data, and locate the file anomexamples.xlsx. Click on the Exponential Data-TR tab. You'll have to tab over several sheets to the right. This is non-normal exponential data from the ANOM book, The Analysis of Means, a graphical method for comparing means, rates, and proportions. Click SigmaXL, Graphical Tools, Analysis of Means, ANOM, ANOM Nonparametric Transformed Ranks. Ensure stacked column format is selected. Select Y. Click Numeric Data Variable Y. Select X and click Group Category X. Set alpha level to 0.01 as done in the book. Click OK. X equals 1 shows is significantly higher than the grand mean transformed rank, and X equals 3 is significantly lower at alpha equals 0.01. These results match those given in the book. By way of comparison, here's the analysis using ANOM one-way normal and an alpha level of 0.01. ANOM normal clearly fails to detect these significant differences in mean due to the non-normal distribution of the data. This concludes the SigmaXL tutorial video for ANOM Nonparametric Transformed Ranks. For more videos, visit us at www.sigmaxl.com or join us on YouTube. Thank you for watching.